Today, we are diving deep into one of the most powerful, maybe the most powerful idea in modern AI. We're talking about attention. This is really the secret sauce, the thing that took AI models from just, crunching data to actually understanding context. I love this quote from Alex Graves at DeepMind because, well, it sounds completely backward, right? The big idea is all about ignoring things. It turns out the breakthrough wasn't about stuffing more and more information into a neural network. Nope, it was about teaching a machine what to filter out, what to selectively ignore. So that's the big question, isn't it? How on earth do you teach a machine to focus? Well, answering that is going to take us on a pretty incredible journey. We're going to go from a noisy party all the way to the very core of the AI models that are, let's be honest, reshaping our entire world. All right, let's get into it. The power of ignoring. And to really get why this is so critical for AI, we're not going to start with computers at all. We're going to start with a situation that I guarantee you've been in before. Yeah, the classic cocktail party problem. Just picture it. You're in a super crowded room, music is playing, people are talking everywhere, but you can somehow just zoom in and focus on the one person you're talking to. You can filter out all that other noise. It's incredible, right? Our brains are just masters of attention, locking on to that one important signal. And here's the thing. For an AI, this isn't just some neat trick. It's not a nice to have. It is a fundamental, absolute requirement for intelligence. I mean, think about it. Without the ability to ignore the junk, a machine is just drowning in a sea of data. It can't make sense of anything. So that brings us to our first big discovery. And this is where the story gets really interesting, because researchers started to notice something kind of spooky. They found that neural networks were already learning how to focus, all by themselves. Yeah, they called it implicit attention. It was like a ghost in the machine. Nobody programmed it in, nobody told the network to do it. It just happened. This hidden, almost unconscious form of focus was emerging automatically. The networks were figuring out on their own what parts of the data actually mattered. And then came the really cool part. They figured out how to see it, how to visualize where the network was looking. They used this mathematical tool, it's called a Jacobian, basically a sensitivity map, to create these heat maps. And these visuals let them see exactly which pixels in an image or which words in a sentence the AI was paying the most attention to. And this led to some amazing insights. Take this Atari-playing AI from 2015. For the exact same game, it learned to shift its focus depending on the job. If the task was predict the score, it would look up at the score display and the horizon. But if the task was what's my next move, like steer left or right, it ignored all that and focused only on the road directly ahead. Super smart. Okay, so this implicit automatic attention was a great start. I mean, a huge discovery. But it got researchers thinking, what's next? What if we could take this unconscious ability and make it a conscious, deliberate choice for the AI? So the first crack at this was something called hard attention. You can think of it like a spotlight. The AI makes a hard choice. I'm looking here and only here. It's efficient, but really tricky to train. The real game changer was soft attention. Now, instead of a spotlight, think of it more like a dimmer switch. It's not a hard on-off. The AI can say, I'm looking mostly here, but also a little bit over there and a tiny bit over there. It's flexible, and crucially, it's something you can train with standard methods. And here was the perfect test case, teaching an AI to generate realistic cursive handwriting. Just think about how hard that is. To draw the word handwriting, the network needs to know exactly when to focus on the H, then the A, then the N, for every single tiny stroke of the pen. It's a massive alignment problem because the timing and spacing is always different. And this solution using soft attention was just beautiful. They called it a soft window. The network basically learned to slide this window of focus across the input text. So it would look at the H while drawing the H, then smoothly slide its attention to the A while drawing the A, and so on. It was perfectly syncing its gaze with its action. And this was the proof, the aha moment. When they visualized it, the heat map showed this perfect, beautiful diagonal line. It was undeniable proof that the network was perfectly aligning its attention. This was huge. By making focus a trainable, soft skill, you could subtly solve all these incredibly complex alignment problems that were impossible before. Okay, so now that we've given AI this incredible ability to focus on the outside world, what's the next logical step? Well, you turn that powerful lens inward. What if a network could learn to focus on its own internal memory? And this idea was absolutely revolutionary. It led to something called the neural Turing machine, or NTM. The core idea was to separate the AI's brain from its memory. It gave the AI an external memory bank, just like RAM in your computer. And why is that a big deal? It meant you could give the AI a massive memory without having to make the AI itself, the processor, any bigger or more complex. And by using attention as the bridge to this memory, the NTM could do something incredible. It could learn simple algorithms just by looking at examples. So to learn how to copy something, it figured out this three-step dance all on its own. First, write the information to memory, row by row. Second, find the beginning of what it just wrote. And third, read it back out, row by row. It was like watching a computer learn how to program itself. Just wild. And the result was a much, much more powerful form of generalization. The machine wasn't just memorizing the examples it saw during training. No, it learned the algorithm for copying. And because it learned the process, it could then apply that process to copy sequences that were way longer than anything it had ever seen before. So this whole journey we've been on, from that ghost in the machine to this idea of an attentional memory, it all leads up to this. It culminates in a single, groundbreaking paper from 2017, a paper that took the idea of attention to its logical and, frankly, its explosive conclusion. The paper's title was Attention is All You Need, and the idea behind it was just breathtakingly simple and so audacious. They basically asked, what if we just got rid of everything else? No more recurrent networks, no more convolutions. What if we built an AI using only attention? Just layers and layers of pure, raw attention. And that architecture, they called it the transformer. And it's the foundation for pretty much all the advanced AI you see today. The way it works is, every single piece of data, say every word in a sentence, can directly attend to every other word in that sentence, all at the same time. This creates this incredibly rich, holistic understanding of context and meaning. And it's super efficient because it can do it all in parallel. And this is where you can really see the power. Back in 2019, one of these transformer models was prompted with a story about unicorns, and it just went off, generating this long, coherent text. It even invented a biologist named Perez. And then, paragraphs later, it would consistently refer back to him. That ability to maintain context over hundreds of words, that long-range dependency, was something previous models could only dream of. And that ability, the ability to handle those long-range connections by attending to the entire context at once, that is the secret. That's the magic behind modern large language models. It's why attention isn't just a part of AI anymore. It has become the central engine of progress. It's the foundation of pretty much every advanced AI we interact with today. So we taught machines to do what we do at a cocktail party. Ignore the noise and focus on the signal. But it leaves you with a pretty big question, right? What happens when they get better at it than we are? From that simple human experience to the absolute core of AI, the story of attention has really been a search for clarity. It's a skill that seems to define intelligence itself, both in us and in our machines. And it is absolutely still pushing the frontier of what's even possible.